we've been working on a project using blockchain technologies to design and test what we call general purpose digital infrastructure. And we mean by that the idea that the infrastructure that we've designed can be used in just about any application case to resolve trade in many, many different verticals. Okay. The use of blockchain technologies aims to resolve what we call in the information security space a question of trust. And we mean by that not the way in which normal human beings think of trust, which is a relationship that we have with other people and a belief that we have in them and those sorts of things, but the extent to which there is a single point of failure within an information system, or where the stability of an information system and the behaviours that people have in response to that information is affected by assumptions that we need to make about the behaviours of one actor, where when we need to have those sorts of strong assumptions about how one actor will behave, we call that a very high trust environment. And the aim of moving down the path towards a lower trust environment is to spread risk, if you will. So there are no single points of information failure, there are no single information bottleneck problems, and that the systems are not exposed to the risks of what we would call capriciousness, which is the ability of single actors to, without warning and in unpredictable ways, make decisions that change the information that we all depend upon. We typically need to make some trade-offs between zero trust, which technically speaking means that we don't have any particular single actor needing to be relied upon, through to a very high trust environment, which is where we need to rely upon very, very small numbers of actors. And you can see here in this chart, that black line basically goes from an environment where through that line, we essentially have unanimity all the way through, from 1 of 1 through to n of n. And unanimity is an expensive thing. If it's getting 100 people to vote out of 100, it takes a lot of effort to make that happen. But at the other end of the spectrum, if we have one person in control of information system, then everyone else is at risk that that person does the wrong thing. So we're trying to design information systems that sit somewhere on that green to pink curve spectrum, where we don't become reliant upon small numbers of actors, but can have information systems that are distributed and resilient. By ensuring that multiple actors are involved in running this information network, we aim to solve a chronic problem in supply chains, and that is information asymmetry. So that's driven by some very old economic research, but it did lay the foundations for some Nobel Prizes. So it was an important body of research work which identified information asymmetry as being the basis of suboptimal markets where consumers lost out and high quality suppliers also lost out. So in markets where there is information asymmetry, where vendors or merchants know more about something than the buyers, then the typical outcome is that mediocre or suboptimal suppliers will tend to dominate the marketplace. What we also know is that asymmetry also leads to higher costs of finance, and by achieving more symmetry, we're able to reduce costs of finance. And our estimates is that supply chain finance costs can be reduced by probably about 10%, which is a very significant whack on export competitiveness. We can also speed up the processes by which money flows, which delivers high return on investment. So for every dollar that gets invested at 0.1 in a supply chain system, over the period of, say, a year, if we can turn that dollar over 3 or 4 times, we're making that dollar work a hell of a lot harder. And by doing that, we're also reducing the amount of what we call dormant capital, which often gets held up in cross-border payment systems, to a point where you can have significant amounts of capital held up for anywhere between 4 to 10 days before it transacts from one part of the world to the other. And when you scale that up, you realize that that's a hell of a lot of capital that is not actually doing anything at all, but it's costing players money. So information symmetry starts to tackle those problems, and that for us is very, very foundational for successful competitive exporting, particularly from high production cost environments like Australia. Okay, the research now is moving from design through to technical implementation, where we have developed a blockchain infrastructure, smart contracts that sit on top of it to enable asset registrations and transacting digital assets, to starting to think seriously about what that means to integrate digital infrastructure and digital ecosystems into a physical environment. And for us, that's very important, because this work is to contribute to how we think about trade hubs and how rolling out physical trade hubs together with digital layers can enable trade to take place between parties and between countries, even in conditions of low trust. And we are now exploring a range of technologies and governance protocols that will enable parties in different parts of the world to manage the information systems that will make it possible for them to do business with each other. In the blockchain environment, that means addressing issues to do with what we call cross-chain protocols. Think of it as enabling information that's been tracked on one particular banking network to be exchanged for information being tracked on a different banking network. And we've got to work out ways of ensuring that that can happen in a smooth and low-cost way. We're also exploring technologies which are cryptographic technologies, such as zero-knowledge proofs. And for us, zero-knowledge proofs, which is a way in which I can prove to someone else that I know something that's important to our transaction without actually revealing that thing, is going to play an increasingly important role in how we resolve the tension, if you will, between the desire for smooth flow of digital information to facilitate commerce and national security concerns around the desire for limiting the flow of information for national security reasons. And cryptography is actually the technical ways in which we can start to resolve those tensions. And zero-knowledge proofs is one of those areas that we believe can lend some very, very powerful tools to enable commerce to function smoothly without giving away the information. Two other things we're looking at very closely is the role of ensuring stakeholder identities are very transparent within the transactional ecosystem, and that's really to drive reputations. For high value, high reputation economies like Australia, being able to prove that the merchant or the supplier is the authenticated Australian supplier, for example, could actually contribute to significant value creation. And the last thing, of course, is when you've got groups of people in different parts of the world having to deal with each other and deal with the information systems that will govern how we collaborate in trade, we also have to think about how we govern all of that. And that is really a piece of policy and legal work that is being thought through in the context of global institutions at a trade organisation level and multilateral trade arrangements such as the Regional Comprehensive Economic Partnership, RCEP, to which Australia is a signatory, and other subordinate agreements that will be arrived at either at a bilateral or a multilateral level. We've got a working demo, which you can link to later in your own time, but our roadmap, and I just got off the phone with one of the devs, is that we should have the next iteration of the mobile app around Christmas time, which will enable users anywhere. And I can't wait to get this in the hands of every member of the CRC and all the partners, Doug, to play with and give us feedback on. But the phone will enable people to literally take photographs of assets, whether they're boxes of things or cattle or whatever they happen to be, and create assets on the blockchain and begin their journey in understanding how tracking and tracing can take place in a decentralized environment. What that allows us to do, and this I think is going to be the really exciting piece, is that we can build customizations on top of that general purpose infrastructure that will suit specific organizations, specific sectors, and specific transactional environments, where we can use dynamic forms to enable the progressive digitalisation of supply chains, whilst making use of the blockchain at the back end to deliver data security.